Hi, I'm Chris Ferguson with the STS-126 crew, and you're watching NASA TV.
Commander Chris Ferguson is putting on his launch and entry suit. Commander Ferguson is a U.S. Navy captain who was born in Philadelphia. Pilot Eric Bowe, a U.S. Air Force colonel. This is his first space flight. He's logged over 4,000 hours in 45 different aircraft. Mission Specialist Donald Pettit. This is his second space flight. He was an Expedition 6 science officer. He spent over 161 days in space. Sandy Magnus. Sandy's a veteran of spaceflight STS-112. She's going to stay on board as the Expedition 18 flight engineer and a science officer. Mission Specialist Heidi Marie Stephanician Piper. Heidi Piper is a veteran of one space flight. She was on STS-115. She's the lead STS-126 spacewalker. She'll conduct 3 spacewalks. Mission Specialist 4, Army Lieutenant Colonel Shane Kimbrough, served in Operation Desert Storm. This is his first space flight, and he will conduct 2 spacewalks. Mission Specialist Steve Bowen, he's Mission Specialist 2, a U.S. Navy captain. This is his first space flight. Putting on his launch and entry suit, he will conduct 3 spacewalks.
Endeavour Launch Director.
Yeah, go ahead, Mike.
Okay, Fergie, vehicle's in good shape, the weather's beautiful, and so on behalf of the entire shuttle launch team, good luck, Godspeed, and have a happy Thanksgiving on orbit.
Kudos to your team, Mike. It's our turn to take home improvement to a new level after 10 years of International Space Station construction. Endeavour's ready to go.
Copy that. Thank you, sir. NTD, with that, you are clear to proceed.
20, 15, 10.
CLS is go for main engine start.
7, 6, 5, 4, 3, 2, 1. Booster ignition and liftoff of Space Shuttle Endeavour, preparing our home in space for a larger international family.
Houston now controlling.
Houston, Endeavour, roll program.
Roger, roll, Endeavour.
Commander Chris Ferguson confirming Endeavour is rolling on course for a rendezvous with the International Space Station. Speed 1,000 miles an hour. Altitude 1 mile. Downrange distance 6.5 miles from Kennedy Space Center already. Throttling down to 72% of the rated thrust as the shuttle goes through the realm of maximum aerodynamic pressure. Altitude 5 miles, downrange 8 miles from Kennedy Space Center. Speed 1,500 miles an hour.
Endeavour, go at throttle up.
All systems remain go. Speed 2,000 miles an hour, altitude 10 miles, downrange distance 12 miles from Kennedy Space Center. It's 1.5 minutes since launch. Endeavour has consumed more than 2.25 million pounds of propellant and weighs less than half of what it did at launch. Standing by for burnout of the twin solid rocket boosters and jettison. Booster officer confirms a clean separation of the two solid rockets. Endeavour's 3 main engines continuing the second stage, accelerating with 37 million horsepower. Booster officer confirms main engine cutoff, standing by for jettison of the external tank. Receiving live television pictures as Endeavour falls away from the external tank. Continues to climb to orbit.
Endeavour Houston, we saw nominal MECO. OMS 1 is not required.
Copy, nominal MECO, OMS 1 not required.
This view from the International Space Station's external cameras showing both the Space Shuttle Endeavour and the Moon as it closes in on the space station from about 9 miles away. Good close-up of the Leonardo multipurpose logistics module with all that equipment that's going to allow 6-person operations aboard the International Space Station tucked inside.
And initiating with the mark. 3, 2, 1, mark. RPM initiating. Mark now.
Expedition 18 Commander Mike Fink coordinating with Endeavour Commander Chris Ferguson on the initiation of the rendezvous pitch maneuver that has now begun. Conditions all favorable to that photography burst that's going to document the condition of Endeavour's exterior hull.
Okay, great, thanks.
This particular view looking past the Japanese experiment module known as Kibo or Hope and its external facility berthing mechanism that is going to be the subject of some testing on the first spacewalk of the upcoming STS-126 mission. Contact.
Underway, capture confirmed.
And so the Space Shuttle Endeavour docking with the International Space Station at 4:01 p.m. Central Time as the two vehicles flew over northern India near the Chinese border at an altitude of approximately 212 statute miles.
And Houston on Space to the Ground 2, we're wanting to know if you're getting NPC audio.
I'm getting reports that we are. I just didn't personally monitor it.
No worries.
As you can see, the hatches between the two vehicles are now open. That occurred at 6:16 Central Time.
Endeavour arriving.
Excellent. You guys are awesome.
1 day, 23 hours, and 21 minutes into Endeavour's mission.
Mike, Commander, how you doing, buddy?
Good to see you.
You look awesome.
You guys too.
Yeah.
Man, that was so beautiful watching you guys come in.
You're
Sandy, welcome to your new home. So glad you're here. Welcome. Hey, we'll do a few words right after this, and then we're ready to go.
All right.
Shane, man, good to see you. Welcome to space. It took you long enough. Heidi, I was just thinking of you the other day. We got your suits already. Oh, yeah. Eric, you're in space, Colonel.
Awesome, buddy. Good to see you.
Yeah.
Hey, you're right. How are you?
The camera's right over there. Good to see you.
Hey, Mike, how's
I
it going?
know you. How you doing, man? Welcome. Don Pettit, this is called a space station.
Wow. Hey, man. Good to see you.
Yeah. Good to see you, man.
Don Pettit on the left and Shane Kimbrough on the right there. Kimbrough at the robotics workstation getting ready to perform a workout with the space station's robotic arm. known as Canadarm2, with help from Pettit as they get ready to reach over and grab the Leonardo multi-purpose logistics module. A pressurized cargo carrier, once again carrying 7 tons of supplies inside that are destined for use and outfitting on the International Space Station. Inside Leonardo are about 7 tons worth of supplies and equipment, new housing features that will add to the number of bedrooms on board the space station, add a second toilet, bring another galley and some refrigeration equipment that will allow the first cool drinks to be consumed on board the station, as well as a new water recycling system that should vastly increase the green levels on board the International Space Station, requiring about 65% less in terms of water delivery.
Hey, Mike, it's your station, buddy.
Oh, I'm with you, man. Don's in there first and me and you next.
Actually, it's a little bigger.
Bigger than the last one, Joe?
It's bigger than I had imagined.
Hey, Spanky, your new sleep station.
Look at that.
And look at this. This is the coffee machine.
Ah, yes. Coffee goes in, coffee comes out.
An unusual sight on board the International Space Station, a live camera view of spiders in operation inside the commercial generic bioprocessing apparatus. It's a part of an experiment designed to help students in kindergarten through 12th grade get involved in science, math, engineering, and cognitive thinking. In addition to the 2 spiders in this apparatus, there are a number of butterflies as well.
Okay, Heidi, you have a go to egress.
Okay, that's the work.
Spacewalker Heidi's Definition Piper carefully managing her tethers as she gets the go-ahead to exit the airlock of the International Space Station.
Okay, it's coming down.
Again, the official start of today's spacewalk at 12:09 p.m. Central Time. A good look at Heidi's Definition Piper in the spacesuit with the red stripes near the end of the space station's robotic arm, Canadarm2, and external stowage platform number 3, where that nitrogen tank assembly rests that's going to be replaced on this spacewalk. First limb in the South Pacific in view as robotic arm operator Don Pettit continues to move Heidi's Definition Piper away.
Heidi, we're ramping out. Okay. Heidi, we're going to start by moving you down into the Paro Bay, and we're starting that motion now.
Okay, Heidi, you can bring it down. Stop motion, Sandy.
Okay, we're stopping.
That's right. Alpha 4 clockwise 2 will be looking for turns and torque.
Here's a view of Heidi's Definition Piper's angle on the activity as she uses that cordless drill to drive home some bolts that will secure the nitrogen tank assembly to the carrier structure.
Roll component, can you?
This Definition Piper now in position at Solar Alpha Rotary Joint cover number 8. She'll be removing covers number 7 and 8 and getting ready for the replacement of trundle bearing assembly in that area. Once that trundle bearing assembly is removed, she will use special cloths to clean the race ring and to apply some lubricant to the ring before reinstalling the trundle bearing assembly.
We have a lost spool. One of my crew lock bags was not transferred and it's loose.
Okay, Heidi, crew lock bag.
Yeah. You see it?
Yeah, we see it. The crew lock bag.
The officers here in Mission Control report that they believe they have enough tools and equipment to complete this leg of the Solar Alpha Rotary Joint trundle bearing assembly removal and race ring cleaning. This is a view from Steve Bowen's camera as he watches Heidi's definition Piper begin to work into getting that lubrication gun with a J-shaped nozzle on it so she can begin lubricating the canted or slanted surface of the race ring.
Okay, Steve, that's good. Once you get the scraper all cleaned up, you can close the debris container. Use a dry wipe if you need to clean up the ring or any of your tools. That'll work.
Back with a view inside the Quest airlock, you can see here Mission Specialist Heidi's definition Piper cleaning off her gloves, making sure to get off any of the brake coat grease that she was using to lubricate the race ring of the Solar Alpha rotary joint. While Piper and Bowen were outside the station on today's spacewalk, the crew left inside was also very busy. Yesterday, after the Leonardo multipurpose logistics module was installed, the crew got right to work and was able to get so far ahead on their task list that they finished the work that had been planned for the day. And so the work planned for tomorrow was moved to today's task list, and they actually finished that several hours ago, getting 3 of the racks brought up by the logistics module moved over to the station, including the water recovery system racks, 2 of those, and the galley rack that will bring up some new kitchen equipment.
Close-up view at Mission Specialist Don Pettit as he continues with his on-orbit science project, hooking up the water recovery system to the appropriate jumpers as part of the environmental and consumable systems on board, getting ready to activate the regenerative life support systems on board the International Space Station. Again, it's going to be about 90 days before this water recycling system can be fully utilized by the crew, as some very stringent tests regarding the quality of the water that's being developed, as urine and condensation from the atmosphere and hygiene water from washing and other activities aboard the station is recycled for use as drinking water. That water also will be available for other uses, such as generation of oxygen. The U.S. oxygen generation system and the electron system on the Russian side both take water and separate it into its components, oxygen and hydrogen. The hydrogen is vented overboard, and the oxygen is then recycled for breathing air, and so water on board is a very precious commodity.
Seeing a view inside the Quest airlock now with Mission Specialist Heidi's definition Piper, and in the background, Mission Specialist Jane Kimbrough wearing their oxygen mask and now getting ready to pull down the hatch of the Quest airlock and start the depressurization of the airlock.
This is a look from one of the truss-mounted cameras on the International Space Station. A reminder that Heidi's definition Piper is in the suit with the solid red stripes around her legs. Shane Kimbrough has the broken red stripes around his legs.
Okay, Eric, what am I looking for a marker on the starboard side?
Starboard side, you're looking for 7650.
Copy, 7650.
Copy.
And Ben, if it's not springing forward, you can press with the remaining steps in that block.
Okay, copy that. Verify sufficient TA clamps are open.
Shane. Okay, I'll open the TA clamp back here.
Copy, and just tell me where you stow that safety tether.
Right now I'm just going to put it on my T-bar, but I'll put it in that crew lock bag later on.
Okay, copy that, Shane, and then you're going to look to relocate the APFR to CETA-2 WIF 1.
Okay.
Okay, you're looking to put that in at the CETA-2 WIF 1, and you're looking for 6 o'clock.
Okay.
Continuing port, and do you still only somewhere zenith?
You can stop the port.
Okay, continuing only zenith?
That's correct. Good motion.
Copy.
Stop motion.
Stop. And Shane, we're now opening the snares.
Okay, I'm ready.
We'll give you a call when you're go for the lee work after it's all complete.
Sounds good. Okay, let's see, snares are open. There's a couple S-curves. The upper right and lower right are S-curves. The one on the left side is in the groove.
Yep, we got great view, Shane. That we see it. Thanks. We see the upper right and the lower right are out of the groove.
Okay, snare is out, Eric. I'm putting the gap gauge away, going for the needle nose.
Three, two, one, mark.
Okay, complete. Push it back in. Okay, it's back in.
It's a view from Mission Specialist Shane Kimbrough's helmet camera. The bag you see attached to his left hand is one of the trundle bearing assembly bags that the crew uses to carry the trundle bearing assemblies they'll be installing, and also to hold the dirty ones that they are replacing so that the debris on them does not get out when they get back to the International Space Station at the end of the spacewalk. Seeing here a view of both spacewalkers working on the starboard solar alpha rotary joint. At the top of the screen is Mission Specialist Shane Kimbrough, distinguished by the broken red stripes on his suit. And at the bottom, Mission Specialist Heidi Stephanician Piper with the solid red stripes on hers. Both spacewalkers are working on cleaning, lubricating, and replacing the trundle bearing assemblies of the solar alpha rotary joints race ring.
And now our first downlink video inside the Quest airlock as the two spacewalkers begin to work on their suits. You can see at the top of your screen, that is Steve Bowen, who will be wearing the suit on the right side of your screen, bearing no stripes, the pure white suit. At the very top left-hand portion of your screen, Heidi Stephanician Piper beginning to work on all of the equipment for her suit, which will bear the red stripes. Piper designated as EV-1, or extravehicular crew member number 1. Steve Bowen, EV-2, extravehicular crew member number 2 for today's third spacewalk.
Okay, GPDT less than 0.5, getting ready to open the hatch.
Okay, and you're go to open the hatch, and inside we'll take the emergency MPIV to close.
And the outer hatch is open on Quest.
Up here.
Flying over the South Pacific Ocean, Heidi Piper at the top of your screen, Steve Bowen at the bottom, working on opposite ends of the solar alpha rotary joint as they work in the cleaning and lubrication of that rotary joint that operates as a paddle wheel to position the large starboard solar arrays that you see flanking the two spacewalkers while the International Space Station orbits the Earth, enabling those arrays to track the sun. A good view of the grease gun being used by Heidi Piper to lubricate outboard race ring, which she tamped down with a wet wipe that had lubricant on it to initially collect any particulate matter which then was collected to try to create as pristine a surface as possible before the new coat of brake coat lubricant could be spread along that area, which you see in this downlink image from Piper's helmet camera. A good look down the starboard truss of the International Space Station, and a good look at Steve Bowen, who is working at his work site. Heidi Piper basically is out of the field of view at the moment, underneath the truss, if you will, working at her work site, as Bowen and Piper work essentially 180 degrees out from one another.
Okay.
Piper wrapping up work with trundle bearing assembly number 12. She soon will install a pair of covers that she removed a short time ago, while Bowen is in the process of cleaning a drive lock assembly, lubricating that area before he installs a brand new trundle bearing assembly in slot number 4.
Aboard the International Space Station, specifically in the Quest airlock, the two spacewalkers, Heidi Piper and Steve Bowen, surveying their suits and the airlock after they completed their spacewalk.
Okay, well, what I have here is a little cup I made from an overhead transparency film that I found. And I've also got a bag of coffee, and we can suck our coffee out from a bag, but to drink it from a cup is hard to do because you can't dip the cup up and get the liquid out, and it's also easy to slosh. So with the special shape of this cup, the surface tension forces will wick the coffee up along the edge there, and as you can see, as I'm putting some coffee there in the bag. And the way this works is the cross-section of this cup looks like an airplane wing, and the narrow angle there will wick the coffee up. And this is what we use when we design fuel tanks for rockets to reignite in a weightless environment. The veins in the tanks will wick the fluid into the suction port. And if that angle is less than 2 times 90 minus the contact wetting angle, then the liquid will rise like that. So knowing this for a fuel tank, you can make it into a cup to drink your fluid from. So you could just sip there right on the edge of the cup, and as you sip, more fluid just keeps coming up and up and up, and you can enjoy a cup of coffee in a weightless environment without having to sip it from a bag. And you can just keep sipping and sipping and sipping, clear down to the last drop in the cup. And this may very well be what future space colonists end up using when they want to have a celebration and do a toast. They can sip their coffee and their tea from cups like this, like we do down here on Earth, without having to suck them from a bag.
Don, we really enjoyed that. This is a lot of fun.
And you can see I'm continuing to suck the coffee out, or actually sip the coffee, because we're no longer sucking out of a bag now. We're drinking from a cup. The coffee continues to climb up that acute angle until the whole bag is drained.
Good to the last drop.
Copy, and you both are egressing. You can obviously see that it's sunlight, so you can go ahead and put your visors down and check your lights on. Visors down, light on, DD2.
This is Mission Control Houston looking at television pictures from outside the International Space Station's Quest airlock as spacewalker Steve Bowen, they're in the suit with no stripes on the legs, maneuvers outside the airlock and closes the thermal cover over the hatchway. He's now moving out to the Port Solar Alpha Rotary Joint location so he can help Shane Kimbrough as they remove the multi-layer insulation covers on the Solar Alpha rotary joint on the left-hand side of the station's truss structure so that Kimbrough can begin his work lubricating the
P3 port side.
Solar Alpha rotary joint on the opposite side from where the crews have been working previously in the mission. Spacewalkers verifying that all of the inhibits for safety measures are in place for the upcoming activity at the Port Solar Alpha rotary joint. First word back from spacewalker Steve Bowen and Shane Kimbrough reporting that they do believe they see some lubricant on the outer canted surface of the race ring on the port side Solar Alpha rotary joint. One of the first jobs for the two spacewalkers there was to do a preliminary inspection of the race ring in its current condition to relay that information down to engineers on the ground who are following along with the spacewalk and getting ready for the lubrication using brake coat grease in the microgravity environment. Steve Bowen and Shane Kimbrough continue their work on the port side Solar Alpha rotary joint, removing the cover so that they can gain access to the race ring inside and provide some additional lubrication. View of the starboard Solar Alpha rotary joint where Steve Bowen is present with a scraper tool for cleaning the joint and the race ring of contaminating metal filings that had been seen in this Solar Alpha rotary joint.
A good look at Shane Kimbrough, now in his second spacewalk of his career, joined by Steve Bowen, wrapping up the third spacewalk of this mission and of his career. All of the work with the starboard Solar Alpha rotary joint now complete and closed out. The first auto-tracking test of the refurbished rotary joint on the right side of the International Space Station, planned for early tomorrow morning in a window that would begin at around 4:30 a.m. Central Time. Kimbrough, having completed the lubrication of the port Solar Alpha rotary joint, went back into the Quest airlock to retrieve an external television camera group, essentially a television camera that you see him holding, plus associated hardware with a stanchion that will be installed at what is known as camera port 7 on the nadir or earthward facing side of the port 1 truss of the International Space Station, primarily designed to provide additional video views on behalf of the rendezvous and approach of the new H2 transfer vehicle, the HTV as it is known, a Japanese cargo ship that will rendezvous with the International Space Station on its maiden flight late next year and be grappled by the Canadarm2 to be berthed on the nadir common berthing mechanism of the Harmony connecting node. A good view of Shane Kimbrough out on the port truss of the International Space Station as he is in the home stretch of connecting a number of electrical umbilicals and connector caps associated with the external television camera group that you see rising on that stanchion, a video camera that will provide additional television capability for situational awareness for the rendezvous and grapple of the Japanese H2 transfer vehicle, the HTV, that will be launched from the Tanegashima Space Center in Japan late next year.
Bowen's finished the installation of 2 GPS antennas that are going to be used in the future to guide the Japanese H2 transfer vehicle to the International Space Station. And as you just heard, the ground team...
Translate down to the handrail like you're doing, and then you're going to do the tether swap back on your 85. Correct.
You just heard the ground team report that they had fired up the heaters on those antennas and everything is looking good on them. The repressurization of the Quest airlock is now in work, and that brings the spacewalk to an official close at 6:31 p.m. Central Time, 6 hours and 7 minutes into the spacewalk.
The Solar Alpha rotary joint on the starboard side of the space station's truss structure went through 2 full rotations overnight in the auto track mode. They reported that they saw no excessive vibrations on that recently cleaned and lubricated solar alpha rotary joint, that the power that was used was looking very close to the same power usage on the port side, which had been functioning normally, but did get some extra lubrication during yesterday's final of 4 spacewalks on the mission. Good look at the cloud cover over the South Pacific behind the space station's Canadarm2 that played a role early on in the space station space shuttle EVAs as it was used to transfer a spent nitrogen tank from an external stowage platform on the International Space Station over into Endeavour's cargo bay, and then take a flex hose rotary coupler system with another nitrogen tank that's used to pressurize the cooling systems on the exterior of the station back to that same external stowage platform.
Now talk a little bit about the machine you're working on that turns urine into water.
Okay. Well, we hooked it up just a couple days after we arrived, and we had a few little technical glitches with it, but I'll tell you, we have some incredible people back in Houston working on these kind of things. The one part in particular that gave us a problem is something called the distillation assembly. What we really do is evaporate urine, and we take the water vapor and we clean it up, and it essentially becomes drinking water. I've actually, in anticipation of your question, we brought a little visual demonstration. First, I'd like to introduce what we would call today's coffee. Okay, and today's coffee is it comes in a bag, and it's a silver bag like this, and we add water to it from the space shuttle's filling assembly, and then we drink it out of this straw. Well, just this morning, we had our first sample come out of the urine processor, and we're calling that yesterday's coffee. So we've managed to, through the technology and the great folks back in Houston and at the Marshall Space Flight Center, turn yesterday's coffee into today's coffee. Now, we're not going to be drinking this today, but you can see these are sample bags set up, and we'll be taking these back to Houston for analysis to make sure that it in fact is fit for human consumption. But beginning probably, maybe next spring or so, we'll get the green light to go ahead and turn yesterday's coffee into today's coffee.
The Leonardo module getting ready for final closeout, making sure everything is secured in its return to Earth configuration, and getting ready to close the hatches. Crew spent much of this morning getting everything squared away and the hatches closed between the Leonardo and the Harmony module so that they could depressurize the vestibule between them. You can just barely see that vestibule here in this picture, and prepare for the arm operations that are coming up now. And this is a look at the grappling target that is being used by Don Pettit and Shane Kimbrough inside the Destiny Laboratory module to drive the space station's robotic arm and its latching end effector into a grapple fixture on the Leonardo module.
It's a view from inside the shuttle's cargo bay as the multi-purpose logistics module moves closer, again controlled by the space station robotic arm being driven by mission specialists Don Pettit and Shane Kimbrough. Teams on the ground reporting that there's just about a meter left to go before the multi-purpose logistics module makes it back into the cargo bay.
What we ended up doing was making another coffee cup, and we decided to propose a toast. So here's our cup filled with tea, and Steve has a cup filled with tea. And again, this is using contact angle wetting phenomenon that rocket engineers use in fuel tanks of rocket to make a teacup. And what we're going to do is propose a Thanksgiving toast on orbit.
Let's do a toast to future space exploration.
To future space exploration. And then do a Thanksgiving toast.
Happy Thanksgiving.
To all our families and friends. We're running out of things to toast for. Let's just toast because we can.
You can drain it pretty well.
Yeah, you can. Because we can now toast. We can now drink like human beings like to drink.
Greetings once again, and again, a happy Thanksgiving to everybody in Mission Control. Before we begin our farewell ceremony, in addition to the accolades that can go around, we have a couple of folks who have been mentioned, but not with enough thanks for everything that they've done throughout this dock mission to make it a success. The first of which is Kevin Window and his entire Sarge team. They've done a wonderful job. The Sarge is up and it's healthy, and we've accomplished that mission objective. And second is our transfer team. The ACO, lead ACO, Caroline Kostak, fantastic job. Our lead transfers are Jeremy Owen, great job to you. And our mid-deck czar, Matt McDonald. And speaking of transfer, we have one final, actually I should say 2 final items that need to be transferred. And for that, I'm going to pass you over to Heidi.
Yes, we have one outstanding resupply item from the mid-deck. And I'd like to present item number 904, and this will complete our transfer list. Sandy Magnus. You are now officially delivered to space station. Thank you.
And in exchange, on the swap list, we have item number 1003, Dr. Greg Shamatoff, also known as Taz. And there's only one. Thank goodness. And now you have your name back. And we'd like to say to Fergie and your crew, thank you very much for this extreme home makeover. And I think we succeeded as a team, not just us guys here up in space, but the entire team down on planet Earth across 15 different nations in something really incredible. I mean, you totally fixed us up on the inside and on the outside, and the results speak for themselves. I think everybody's really ecstatic, and I'm really proud to have worked with you. So on behalf of the space station, I'd like to say thanks for coming. On behalf of myself, this is the first time I've seen a space shuttle up here, and I didn't know what to expect. And boy, you guys set the bar high for the next crew, because boy, it was so much fun having you here and seeing you here. And you guys were such perfect guests. You left the place cleaner than you found it, and we tried to make it pretty clean for your arrival, and it's even better now. And we're just so glad. And then you brought us Sandy. Sandy, welcome. We're really glad you're here. We got a lot of work to do, and you're definitely the person for it. And you're replacing Greg. Boy, no words can really describe Greg's missions. It's so outstanding. First starting on Expedition 17, then he came to us on Expedition 18. And Greg, I'm really proud and really glad to have served with you. You've accomplished so much, just the normal day-to-day work, plus all the science that you got done. And I'm really proud to have served with you. And you're leaving on such a good high note.
Again, words can't express the thanks we have for all the folks who supported this dock mission, both in the White Ficker and over in Ficker 1. You know, we can't thank you enough. As far as my tally is, we've accomplished all the major mission objectives, and when I say we, I don't mean just the 10 of us. I mean everybody in both flight control rooms and all our supporting personnel as well. So. With that, I think that we'll drag Taz, and we'll also make sure that Dr. Don Pettit stays on the right side of the hatch when we leave. I've been told to keep a good eye on him for fear that he might sneak away from us. So with that, I think that we'll bid a fine farewell to this Expedition 18. Good luck in the rest of their stay up here, and we wish Sandy could come back with us, but we know that she's answering to a higher calling right now. So with that, we'll finally drag Taz with us.
I just took a final look out the window in the Japanese module, and I just cannot believe that 6 months has gone by. It feels like it's ending very much the way it began, with the spectacular shuttle flight and accomplishments of the shuttle crew that are really amazing. They've given us a makeover both inside and outside the space station, prepared us for a 6-person crew in the future. And it's been a real pleasure to see this crew come up after being on board for 6 months, mostly with 3 people at a time. And all of a sudden, there's 10 people up here, and the work they've done is just amazing. It was great to see it, and seeing the smile on their faces and their wide eyes as they came into the station reminded me of what it was like when I first arrived here 6 months ago. And that amazement hasn't left. That amazement has stuck with me the whole time. This is such a spectacular space station, and I'm very proud to be leaving it a better space station than the one we found when we got here. We installed a new Japanese module. It's a spectacular new laboratory, and everything in there is working great. The Japanese people need to be very proud of their new spacecraft, and we've done a lot of work in the Columbus module as well, a lot of science. It was also a very new module when I got here, and we've done a lot of great work in there. So congratulations to the whole team all around the world, all the control centers, 15 different countries that have worked to build the space station and make it what it is today. It's really a spectacular place. And as I leave it today, I feel both happy and sad. Very sad to leave my crew because my crewmates have been just terrific, and I know that I'm leaving this space station in really the best possible hands with Mike as the commander. We've had a terrific time for the past 7 weeks now, and I regret having to leave and not be here to see the end of Expedition 18, which I know is going to be just continue with great success with Yuri and Sandy. I know that this space station is in great hands, and of course I'm really happy because I'm really looking forward to seeing my family as I head through the hatch, or maybe go the wrong direction and someone helps me find the hatch. I'm really looking forward to seeing my family. I just can't wait to get home and see my family. All my thoughts are there now.
And this is a look at the aft flight deck of the shuttle Endeavour with pilot Eric Bowe on the left, who'll be doing the fly around. On the right is mission specialist Shane Kimbrough. Coming into the frame at left is Greg Shamatov coming home after 6 months on orbit. Lower right-hand portion of your screen is the mission specialist Don Pettit, and just obscured is Heidi Stephanician Piper.
Physical SEP, Houston.
Houston copies. Physical separation.
Station copies.
Endeavour departing.
Thank you, Sandy. It was great working with you guys. And Endeavour, this is the International Space Station. We're great. Thanks for the incredible makeover and leaving the station in fantastic shape. And thanks to your heroic efforts, we are one step closer to a 6-person crew. So from the International Space Station, Godspeed, soft landing. We copy ISS, thanks. And even from 25 feet, you look better.
Copy that, and thanks, Fergie. See you guys in a few months. Safe landing.
Former Endeavour crew member and now Expedition 18 crew member Sandy Magnus rigging the ship's bell aboard the International Space Station to signal the departure of Endeavour. And Space Station Commander Mike Fink thanking Chris Ferguson and his crew for an incredible makeover.
Endeavour Houston on air to ground 2. Looks like Colonel Bowe is doing an outstanding fly around.
Endeavour Station station on the big loop. We saw you pass right below us, and you look, as far as we can tell, clean and dry from the top. Some mighty spectacular imagery we got as you flew over the mouth of the Amazon River. So good job, and good flying to Eric.
ISS Endeavor on the big loop. Yeah, we concur. You guys look great from this perspective, too. Eric's doing a great job.
Endeavor Houston, you're on energy approaching the hack. No changes to winds or weather. Nominal shoot deploy.
Okay, no change to winds and weather. Nominal shoot.
Speed just over 500 miles an hour, 25 miles to the landing site. Commander Chris Ferguson has taken over the controls of the shuttle as he arrives at the heading alignment circle. Again, this is the 342-degree left-hand turn to line him up for Edwards runway 04, a temporary runway that is providing a southwest to northeast landing. Speed 530 miles an hour. Altitude 6 miles. 21 miles to the landing site.
Endeavor, on at the 180.
On at the 180.
Pilot Eric Bowe now getting a chance to get the feel for Endeavor as it returns from Earth to Earth. Speed 470 miles an hour. Altitude 20,000 feet.
Endeavor, on at the 90.
On at the 90.
Commander Chris Ferguson back in control. Endeavor on course past the 90-degree portion of the heading alignment circle. Lining up with runway 04, Edwards Air Force Base. Speed 400 miles an hour. Altitude 1,100 feet. Commander Chris Ferguson on glide slope. Speed 350 miles an hour. Altitude 2,000 feet. Landing gear down. Gear down and locked. Touchdown. Pilot Eric Bowe deploying drag chute that'll help slow Endeavour on the runway. Nose gear touchdown. Final reveal for Endeavour's home improvement to the International Space Station mission is now complete. 124th Space Shuttle mission, 27th shuttle mission of the station, and the 22nd mission for Endeavour.
Copy, wheel stop Endeavour. Welcome back. That was a great way to finish a fantastic flight, Fergie.
Hey, we're happy to be here in California.
First, let me just say thank you to all the folks who came out to support the landing at Edwards Air Force Base today. Kind of a unique opportunity to come out and land at this temporary and narrower runway, but I think it all worked out in the end very well. Let me be the first to say that the crew members who are not with us are doing just fine. Greg Shamatov, of course, is a 6-month space flyer, and it takes just a little bit longer for them to reacclimate to the gravity and readapt to being on Earth again. And then Don Pettit and Heidi Piper doing just fine as well. They're in keeping a good eye on Greg. So we just thought we'd take advantage of the beautiful weather to come out here and enjoy this gorgeous orbiter, which seems to have fared entry pretty well. And let me thank all the folks back in Houston and at the NASA centers throughout who went to support what I believe is an extremely successful mission. It was very ambitious. It was over 15 days long. We were the home improvement mission. We improved the space station inside and out, of course, with a new water recycling system, and then the Solar Alpha rotary joint, which Heidi and her team so adeptly managed to repair. From what I've heard, is performing very well. So again, thank you to all throughout the Edwards and NASA communities who've supported us today, and it's great to be back on the ground, and it's great to be in California. Thank you very much.
STS-126 crew arrives back at Ellington Field. The STS-126 crew arrived Monday, December 1st at Ellington Field in Houston after completing its mission to the International Space Station and landing Sunday at Edwards Air Force Base, California. Weather concerns prevented the crew from returning to NASA's Kennedy Space Center, Florida, the primary end-of-mission landing site. The 16-day mission featured important repair work and prepared the station to house 6 crew members on long-duration missions beginning next spring. The flight delivered station crew member Sandy Magnus to the complex, replacing Expedition 18 flight engineer Greg Shamatov, who returned to Earth on Endeavour after more than 5 months on the station. The other crew members are Commander Chris Ferguson, pilot Eric Bowe, and mission specialists Don Pettit, Steve Bowen, Heidi Marie Stephanician Piper, and Shane Kimbrough. For more information, log on to www.nasa.gov.
We put people in space and payloads in space, and we bring them home on a fairly regular basis. And that is extremely unique, and you can all be extremely proud of the part that you play in that. So I would like to thank you all. These guys made it all happen. We had our 4 teams. We had our flight deck team. Our flight deck team was, the core team was Eric Bowe, the pilot, and we had Steve Bowen, the mission specialist. We had the robotics team. The robotics team was Shane Kimbrough at the end there, who has his own personal cheering section. Also joining Shane on robotics was Eric Bowe, and you'll see Eric Bowe's name come up a lot here. And we had Don Pettit over on the space station robotics side. He did a lot with what we call the big arm. And of course, we can't leave out Sandy Magnus, much to our disappointment, but I'm sure to her joy. We had to leave her aboard the International Space Station, and she's there today doing an awful lot of work, and she was very busy while we were there. We also had our EVA team. Our EVA team was led by Heidi Stephanician Piper. Heidi had a lot of press time on this mission. Joining her on the EVA team was down at the end, of course, there, Shane Kimbrough, who did 2 EVAs. Steve Bowen, who did 3, including his first lead EVA as an EV4 on EVA 4. He did a wonderful job on that. And then kind of our in the hole player, also Eric Bowe, was a guest IV, did a lot of quarterbacking from inside the space shuttle. And then finally, we had our transfer team. Our transfer team was led by none other than Don MPLM Pettit. And the one unsung crew member who is quietly recuperating in a horizontal position is Greg Chamitoff, who spent 6 months on the space station. You know, coming back and readapting to G is not an easy thing to do. Greg was instrumental in our success up there because he was the all-around gopher guy. You know, Greg, help me find this. Greg, help me do that. Greg, can you show me where this is? Greg, can you show me where that is? And he never skipped a beat. He had a lot of personal things to do, and he did it all absolutely wonderfully.